Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
All right, welcome back. We are adding up some more vectors today. So we have a vector that points due west, which I'll draw my compass rose right here: north, west, south, and east. All right, so we have a vector pointing due west of 63 units, and another one. We're adding the vectors, so the head of this vector right here is going to connect to the tail of the vector we're adding it to. And that vector goes due south and has a length of 63 units. We'll call this vector A. This one right here, vector B. All right, so A plus B is going to equal to, we'll call this vector C right here. I'll draw it in green. Green's a lovely color. All right, vector C is this one right here. All right, and so if we want to find the magnitude of vector C, we can use the Pythagorean theorem. And that'll give us C is equal to A squared plus B squared. So 63 squared plus 63 squared. I can rewrite that if I want to as 2 times 63 squared, right? And that will be equal to about 89 units. All right, so that is the magnitude. The direction, we can see that this is going to be an isosceles triangle, right? This side right here is equal to this side right here. So we know that this angle then, I'll draw it in red right here. This angle is going to be equal to this angle. And this angle is equal to 90 degrees. So if we do 90, or rather 180 degrees minus 90 degrees minus 2 times an angle theta, where theta is this angle right here and this angle right here, because they're equal of magnitude. That'll equal 0, right? All right, so if we start doing some math there, we'll find that 90 is equal to 2 times theta. So theta, oops, ran out of space. Theta is equal to 45 degrees. So it's going to be 45 degrees south of due west. I'll write that in right here. 45 degrees south of due west. All right, now we're going to have a similar problem right here. A minus B, and we'll call this other vector right here D, just so that we don't get our vectors confused. So to find that, if we were to change B to a negative, that would make it point in the opposite direction, so upwards. That's actually going to give us a very similar answer to part A. Right, it's going to be the same magnitude because we're basically just treating this as if we were to flip the image on this axis right here. So the magnitude of vector B, vector D is also equal to 89 units, for the same reason that vector C is 89 units. The only difference is it's going to be 45 degrees north of due west. And there you have it. Hope that was helpful. Good luck on the rest of your homework. and see you next time.